So hello everyone. So today we are going to study about sulfur dioxide and then we will go with the contact process of sulfuric acid. So sulfur dioxide and sulfuric acid are very important question as exam point of view. Please you have to focus this. Sulfur dioxide question is also very important. Sulfuric acid contact process is also very important, and oxoacids of sulfur. These three questions are very important. Sometimes what happens, most of the time it has been observed that in the exam, if a teacher wants to set up a question paper from group number 16, if he is thinking that this time I should ask the question from group number 16, so these are the most favorite question of a teacher. Clear? So sulfur dioxide contact process means most important. In the starting of the lecture itself, in the starting of the group itself, I told you that contact process, sulfur dioxide and the oxoacids of sulfur are very important. So you have to focus here. Clear? So today we are going to study about the complete sulfur dioxide preparation, properties and uses. After this I will go with the contact process. So first we will go the preparation of sulfur dioxide. Sulfur dioxide molecular formula is SO2. This everyone knows this. Okay. So preparation is laboratory. First we will see the laboratory preparation. So in laboratory we can prepare from either from Na2SO3, from copper. Second we can prepare from industrial preparation, that is from burning or combustion of sulfur products, and from the combustion of sulfide minerals. So first we will see from the laboratory preparation. So along with me please you also write down. So write down laboratory preparation. See, in first laboratory preparation, first you see the reaction, then I will give you the notes. Along with you write down the notes also. So what happens, from Na2SO3. So this Na2SO3 is first reacted with HCl. Clear? Is first reacted with HCl. When it is reacted with an HCl, so it will produce what? NaCl, H2O and SO2. That's it. So this is the laboratory preparation of sulfur dioxide gas. Write down. So when write down sulfur dioxide is obtained by reacting sodium sulfite. This reaction, this compound name is sodium sulfite. By reacting sodium sulfite with hydrochloric acid, by reacting sodium sulfite with hydrochloric acid, by reacting sodium sulfite with hydrochloric acid, NaCl, H2O and SO2 are produced. Clear? Clear this part? Next it is from copper. Write down. From copper. This is bit important. In laboratory it can be also prepared from copper. Write down. In laboratory it can be also prepared from copper by heating the copper foils. Write down. By heating the copper foils in the solution of aqueous sulfuric acid. In the solution of aqueous, or you can write down, sorry, not aqueous, concentrated. You can write down in concentrated sulfuric acid. Please write down this. So you have to take the copper foil, that is copper solid, and you have to take the H2SO4 bit concentrated and you have to heat it. When you heat it, you will get here CuSO4 plus H2O plus SO2. So write down this. So this is the laboratory preparation of sulfur dioxide. So this reaction is bit important. Please remember this. Okay. See, remembering this reaction is nothing but a metal plus acid. Remembering standard 10. So metal plus acid will give what? Metallic salt plus hydrogen gas. But remembering copper is less reactive than hydrogen. So when copper is less reactive than hydrogen, so instead of H2 it will generate H2O along with the sulfur dioxide one gas. Remember standard 10, metal plus acid gives metallic salt plus hydrogen gas. But in that, if metal is copper, so as we know that copper is less reactive than hydrogen, so copper cannot replace the hydrogen, so hydrogen gas will not be liberated when copper is reacted with acid. Instead of hydrogen, H2O, and along with that H2O either SO2 or SO3 will be generated. So this is this reaction, very important. Write down. Clear? Clear this part? So these are the laboratory preparation. In this laboratory we can prepare, and this sulfur dioxide is having a very pungent odor. So as soon as when you heat the copper foils and sulfuric acids, so due to the pungent odor or suffocating odor, you can identify that sulfur dioxide gas is generated. Clear? Clear this part? Written this? Written? Okay. So next we will go to the industrial preparation. This is very simple. So write down. Next is industrial preparation. Industrial preparation. Industrial preparation. In industrial preparation is first is from burning of sulfur, or by the, you can say by the combustion of sulfur. So you have to take the sulfur product S, yes or no, and you have to burn, means adding of oxygen because you are doing the combustion. So when you burn in the presence of an oxygen, or when you do the combustion, it will generate SO2. Okay, it will generate what? SO2 gas. Along with this SO2, 6 to 8% SO3 also will be generated. Please remember this. I will give you the notes. So along with SO2, when sulfur is burned or when sulfur is combusted in the presence of an oxygen, sulfur dioxide gas is generated. Along with this sulfur dioxide gas, nearly being as an impurity, 6 to 8% sulfur trioxide is also generated. Write down this. When sulfur is combusted, first you write down the topic, then you write down this reaction. First you write down. When sulfur is combusted in air, sulfur dioxide is produced. When sulfur is combusted in air, sulfur dioxide is produced. Along with sulfur dioxide, nearly 6 to 8%. Along with sulfur dioxide, nearly 6 to 8% sulfur trioxide is also generated. Nearly 6 to 8% sulfur trioxide is also generated. Nearly 6 to 8% sulfur trioxide is also generated. Clear? Next you can add down from the combustion of sulfide minerals. So this is from sulfide minerals. As we know, it is used in the metallurgical process. We have a sulfide mineral like FeS2, or we have a AgS, silver sulfide, yes or no, or copper pyrite, CuFeS2. Okay, so these are nothing but what? Sulfide minerals. Out of this, any sulfide minerals if you take and when you burn it, for example, I will take the example of FeS2 as given in your textbook. So when you take the sulfide mineral like FeS2 and when you burn in the presence of an oxygen, that is when you do the combustion, so what will happen? You will get Fe2O3 plus SO2. So sulfur dioxide also can be generated from the sulfide mineral in this way. Write down. Write down. In the metallurgical industry, write down, in metallurgical industries, sulfur dioxide is generated as a byproduct. Sulfur dioxide is generated as a byproduct. When sulfide mineral is, you can balance at your home. When sulfide mineral is combusted, as shown follow. Clear? Write down this. Write down this reaction. FeS2. Instead of FeS2, you can take AgS also. So it will form here AgO plus SO2. Instead of CuFeS2, I can take CuFeS2 also. So we will obtain here Cu2O, Fe2O3 and SO2. But you take the simple example which is given in your textbook, that is FeS2. Clear? Write down. The sulfur dioxide so obtained in the industry. Now this is the sulfur dioxide gas. Okay, so sulfur dioxide gas so obtained in the industry. Write down this main point. Sulfur dioxide so obtained in the industry is dried and liquefied. The sulfur dioxide so obtained in the industry, it is dried. Dried means you have to remove certain impurities, certain ashes, means you have to purify. So it is dried and purified and liquefied under a very high pressure and low temperature, and stored in a cylinders. So where it is used? It is used in the industry of sulfuric acid. Many industries it is used, okay. But most important use of a sulfur dioxide is also one, that is a contact process, okay. So write down this. So sulfur dioxide so generated, it is dried, purified and liquefied at a very high pressure and low temperature and stored in the cylinders. Clear this part? So this is the preparation. Next we will go to the physical properties of sulfur dioxide. So the next topic is physical properties of sulfur dioxide. So you can make a note of sulfur dioxide. First you listen and understand, then you can take a screenshot and copy out it, okay. So first physical property is, it is colorless but toxic gas and having a pungent odor, or we can say it is having very suffocating odor also. You will get suffocating odor. Means you will feel difficult in breathing when you inhale sulfur dioxide. So first property is very important. It is a colorless gas, toxic, having a pungent odor, or we can say as a suffocating odor. Clear? Next we can say it is highly soluble in water. Why? I will explain, so don't worry about it. So I will tell what is the reason that sulfur dioxide is highly soluble in water. Just now only I will tell, and it is very simple reason, you will also understand. Clear? So sulfur dioxide is highly soluble in water. Boiling point 263 Kelvin. It liquefies easily at room temperature under pressure of 2 bar. We know that what is the condition of liquefaction of any gas? Low temperature and high pressure. So temperature you supply, if you supply very low temperature, so at a low temperature like 263 Kelvin. So at 263 Kelvin what will happen? It will liquefy easily, but it will supply high pressure, and that also not required very high pressure as of carbon dioxide. at nearly 2 bar pressure. Clear? Now sulfur dioxide is having an angular molecule. Why it is an angular molecule? This we have to see. See, this is a sulfur dioxide structure. Okay. So angle OSO is 119 degree and 143.1 picometer is the bond length of the S and O. Now see here if you count, so 1, 2, 3, 4, 5, 6. So here will come 7, 8. Means sulfur dioxide is having one lone pair. Yes or no? 1, 2, 3, 4, 5, 6. So one lone pair will come. Why one lone pair? Sulfur belongs to the 16 group and 16 group is an electron rich group. So one extra electron pair will come. That is one lone pair. Clear? So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. If this bond gets shift here, so what will happen? See this? 1, 2, 3, 4. So 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So here one lone pair will come. Clear? Or this bond can be here, and if this bond gets shift, so this bond will come here. So instead, you know this molecule, partial half of bond will come there. Now, first, why the structure is bent? Why the structure of sulfur dioxide is bent? So it's very simple, due to the repulsion between lone pair and bond pair. So this is lone pair and this is bond pair. So there will be a repulsion here. So due to the repulsion, the bond cannot be linear like carbon dioxide. As you know, carbon dioxide shape is linear. Yes or no? Because there is no lone pair. Similarly, I cannot write down like sulfur dioxide. Sulfur dioxide will be this. Okay, but after counting the electron pair, I have one lone pair here. So this lone pair and this bond pair will have a repulsion. This bond pair and this lone pair also will be having a repulsion. Due to the repulsion, the bond will become bent. That's why sulfur dioxide structure is bent. And when it becomes bent, it makes an angle how much? 119 degree. Now, next point. Okay, so we will see this why sulfur dioxide is having a highly soluble in water. So see. Sulfur dioxide, if you see the structure, is SO. After writing the SO, 1, 2, 3, 4, 5, 6, 7, 8, one lone pair here, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And you can take here water. So water formula is H2O. Now see here, this hydrogen requires one lone pair to make a bond. So here there is an oxygen. So oxygen will donate its lone pair to the hydrogen of H2O. So oxygen of a sulfur dioxide having an excess electron will donate its lone pair to the hydrogen of water, due to which excessive hydrogen bonding is possible between the oxygen of sulfur dioxide and between the hydrogen of H2O. Hence hydrogen bonding occurs. Due to this reason, sulfur dioxide is highly soluble in water. Clear this part? Okay. So next it is liquid sulfur dioxide is a good solvent for some substance. Yes or no? So this you have to remember that liquid sulfur dioxide is a good solvent for some substances. Next, this fifth property is very important, that the gas is colorless. Yes or no? This gas is colorless, but when it is liquefied, so liquid sulfur dioxide is also colorless, and this liquefaction occurs at 263 Kelvin. But further it is cooled. If it is further cooled and go to the from 263 to directly, if you go to 203 Kelvin, if it is further cooled, or instead 263, you can write down 293, I guess. It is 293. You can write down here 293, sorry. It is 293, okay? Or you can check it out and please tell me, let me know, okay? So what you do, you have to take sulfur dioxide and you have to cool. When sulfur dioxide gas is cooled and it is converted into liquid at 263 Kelvin, so it will be colorless liquid. But further, if it is cooled and goes to the 293 Kelvin, if it goes to the 293 Kelvin, it will convert into the snow-like solid. It will go to the snow-like solid. So please remember, if sulfur dioxide is a liquid, these temperatures are not important, but then also you check it out. Sulfur dioxide, if it is a liquid, colorless, but sulfur dioxide is a gas, it will form like a snow-like a substance. Please remember, once more I repeat, sulfur dioxide, if it is a liquid, it will be colorless, but sulfur dioxide, if it is converted into solid, so it will be snow-like. Okay? So these are certain physical properties of sulfur dioxide: colorless, it is having a suffocating odor, pungent odor, and toxic gas. It is toxic. Okay? Highly soluble in water due to excessive hydrogen bonding between the oxygen of SO2 and between the hydrogen of H2O. Okay? So boiling point 263 Kelvin, it easily liquefied at room temperature under a high pressure like 2 bar. It's not very high pressure. Okay? Sulfur dioxide is having an angular molecule. Why it is having an angular molecule, or we can say bent molecule? The reason is due to the repulsion between the lone pair present on the sulfur and between the bond pair of sulfur dioxide. Clear? So between the repulsion between this lone pair and this bond pair, the bond become bent. Okay? The bond angle is nearly 119 degree, and know this. Okay, so liquid sulfur dioxide is a good solvent for certain substance, and this is very important. If sulfur dioxide is a gas, it will be colorless, but if it is converted into solid, it will be snow like a substance. So next we will go to the chemical properties, which are very important for your today's class. So next we are going to see the chemical properties of sulfur dioxide. This is very important question, and there are only 5 properties, so don't worry about it, but very important. Clear? It's very important. Clear? So first property is, when sulfur dioxide gas is passed through the water, sulfurous acid is formed. So this is very simple, because sulfur dioxide being a non-metallic oxide, and as you know that non-metallic oxide are acidic in nature. So when sulfur dioxide dissolves in the water, so it forms a what? Sulfurous acid. So write down, when sulfur dioxide is passed through water, it will generate what? Sulfurous acid. So this is sulfur dioxide gas. When it is dissolved in the water, it will form what? It will form H2SO3, which is known as sulfurous acid. Which is known as a what? Sulfurous acid. So when sulfur dioxide is dissolved in the water, or when passed through in the water, when dissolved in the water, it generate what? Sulfurous acid. Next, reaction of sulfur dioxide with NOH. So the next is reaction of sulfur dioxide with NOH. Sorry. Okay. So the reaction of sulfur dioxide with NOH. So in this reaction, the reaction of sulfur dioxide with NOH, in this reaction occurs in 2 steps. How? See, in first step, what you do, you take NOH aqueous form, and this in NOH aqueous form, sulfur dioxide is dissolved. As you dissolve the sulfur dioxide in aqueous form of NOH, it will generate Na2SO3, that is sodium sulfite plus H2O. This sodium sulfite, Na2SO3, it is further reacted with again with SO2 or plus H2O only. Yes or no? So this whole portion, that is plus H2O plus SO2, it is further reacted with SO2 and generate what? NaHSO3, sodium bisulfite, and this is sodium sulfite. Clear? So please remember, see, whenever you react sulfur dioxide with aqueous NOH, so final product is sodium bisulfite. But this reaction occurs in a 2 step. How in 2 step? First sulfur dioxide will react with NOH and it will form sodium sulfite. Okay, this sodium sulfite is further made to react with the sulfur dioxide in aqueous medium itself. It will generate sodium bisulfite. So this reaction is also very important. Reaction with chlorine. So sulfur dioxide will react with chlorine, but in the presence of a catalyst known as a charcoal. It will react with chlorine in the presence of a catalyst as a charcoal, and it will generate one compound known as SO2Cl2, which is known as a sulfuryl chloride. Clear? So it will generate one compound known as a sulfuryl chloride. Fourth property, that sulfur dioxide is oxidized to SO3 in the presence of V2O5 as a catalyst. Clear? You can write down. Okay. So sulfur dioxide is oxidized to SO3 in the presence of a V2O5 as a catalyst. So this is sulfur dioxide will oxidized. Okay, means, or you can write down here O2. Here. So it will form what here? SO3, and this reaction is reversible in the presence of V2O5 as a catalyst. And this reaction is a key step reaction in contact process. So please remember this. This reaction is a key step. Please remember this. Okay. So this reaction is a key step reaction in a manufacturing of a sulfuric acid. So sulfur dioxide is oxidized. See, it is oxidation. Okay, yes or no? So see, here sulfur dioxide has been converted into sulfur trioxide. So here sulfur dioxide is having 1 oxygen, and here there were 2 oxygen, but here there are 3 oxygen. So sulfur dioxide is undergoing oxidation, and one who undergo oxidation, they are also known as a reducing agent. So see here, sulfur, this can be also example as a sulfur dioxide as reducing agent. You see another example, 5th property, write down along with me, as reducing agent. Write down, sulfur dioxide act as a reducing agent. Please write down the please write down along with me in the fifth property. Sulfur dioxide act as a reducing agent. It decolorize the acidic KMnO4 solution. It decolorize the acidic solution of KMnO4, which is purple in color. It decolorize the acidic solution of KMnO4, which is purple in color. So see what I am taking, I am taking MnO4, KMnO4, that is MnO4 minus, and this is acidic, okay, along with water. So this is an acidic solution of KMnO4, and this solution is a purple in color. Which color? Purple in color. As soon as you pass the sulfur dioxide gas, what will happen? The purple color will turn into colorless. Why? Due to the formation of Mn+2, Mn+2 only. Yes or no? Sorry, Mn+2. Okay, H plus and SO4 minus 2. Clear? So these compounds will be correct. Now see here if you calculate, see once more I will explain this, that when you pass the sulfur dioxide gas in the acidic solution of a KMnO4, which is purple in color. So this is the acidic solution of KMnO4, which is purple in color, and when you pass the sulfur dioxide gas, so the solution turns colorless. So this turns with what? Turns colorless. So this substance is colorless. Why this is colorless? Due to presence of Mn+2. See here Mn is +7. You can calculate 4 2s are -8. +8 -1 +7. So here Mn is +7, but here Mn is +2. So Mn+7 is color compound and Mn+2 is colorless. Remember the D and F block elements. Okay. So this is color compound, which is purple in color, but Mn+2 is colorless compound. So due to which, anyone can ask you, why sulfur dioxide turns the purple color solution of a KMnO4 into colorless? Due to the formation of Mn+2. Clear? Now this reaction also can be the example of reducing agent of sulfur dioxide. How? See count the oxidation number of sulfur here. 2 2s are -4. If you go that side, so here +4, and here 4 2s are -8. If you go that side, +8 -2 +6. So see here +4 to +6 is nothing but a what? Oxidation. One who undergo oxidation, they are known as a what? Reducing agent. So sulfur dioxide is acting as a reducing agent. So this can be also example of a reducing agent of a sulfur dioxide, and this can be also example of a reducing agent of sulfur dioxide. So write down that it acts as a reducing agent. And hence turns a purple color acidic solution of KMnO4 into colorless. And turns purple color solution of KMnO4 into colorless. Clear this portion? Clear? So there are how many property totally? There are only 5 property. Very simple property. First property is what? That sulfur dioxide gas, when passed through the water, it will generate a solution. Aqueous solution of sulfur dioxide is known as a sulfurous acid. See, lower us, higher ik. Before that also I told you. So H2SO3 is sulfurous, but H2SO4 is sulfuric. Clear? Then next, when sulfur dioxide is reacted with NOH, so this reaction also you can remember in another way. See, NOH is a basic in medium, NOH is a base. Sulfur dioxide is a non-metallic oxide, and non-metallic oxide are acidic in nature. So this reaction is nothing but what? Acid and base will produce what? Salt plus water. Are you understanding? See, NOH is a base and sulfur dioxide means what? Non-metallic oxide. So this is a non-metallic oxide, and non-metallic oxide are acidic in nature. In short, this is an acid, this is a base. So acid and base will generate what? Salt plus water. So salt plus water. So salt is here Na2SO3 plus H2O. But here reaction is further reacted. That this product, if it is further reacted with SO2, so it will generate bisulfite. This you have to remember. Reaction with chlorine, so it will occur as in the presence of a catalyst as a charcoal. So it will generate sulfuryl chloride. This is important. Next, sulfur dioxide is oxidized to sulfur trioxide in the presence of a vanadium pentoxide as a catalyst. Clear this part? And this reaction is most important because this is a key step reaction in the manufacturing of contact process. Next, and this can be also example of a reducing agent of sulfur dioxide. Another example of a reducing agent of a sulfur dioxide, that when sulfur dioxide gas is added to the purple color solution of a KMnO4 of acidic medium, it turns colorless. Why it turns colorless? Because the MnO4 minus will be converted into Mn+2, and this Mn+2 compound will be colorless. Next, why it is a reducing agent? Example, see the sulfur dioxide, sulfur oxidation number is +4. In sulfate, the sulfur oxidation number is +6. So +4 to +6 will be oxidation, and one who undergo oxidation, they will act as a reducing agent. Clear this part? So in this way you can remember the chemical properties of sulfur dioxide. Next, you can write down along with me uses of sulfur dioxide. Please write down Uses of sulfur dioxide. Everyone ready? First write down. It is used in the purification of sugar. It is used in the purification of sugar, petroleum products, etc. It is used in the purification of sugar, petroleum products, etc. Next, write down. It is used to bleach the delicate fibers like wool, silk, cotton fibers, etc. It is used to bleach wool, silk and delicate fibers like cotton. Next, liquid SO2 will act as an organic solvent for certain substance like sulfur, phosphorus, iodine. Liquid SO2 will act as an organic solvent for a certain substance like sulfur, phosphorus, iodine, etc. Next, it is used in the manufacturing of products like sodium sulfate, sodium bisulfite, sulfuric acid, sulfur trioxide, etc. Clear? So you can remember the uses. Next class we will see sulfuric acid. Thank you.